Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers bearings. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 2. Circle the ratio which is the same as the scale 1 centimetre represents 2 metres. Now you notice we've got different units here. I've got centimetres and metres, and I happen to know that 100 centimetres is the same thing as 1 metre. So I can rewrite this as 1 centimetre represents 2 times 100, which is 200 centimetres. So then the ratio of 1 centimetre to 2 metres is the same thing as 1 centimetre to 200 centimetres. So it's that one there. Question 18. Circle the ratio which is the same as the scale 1 centimetre represents 1 kilometre. 1 centimetre is 1 kilometre. Okay. Well, I know that there are 1,000 metres in a kilometre. So what's that then? So 1 centimetre then is the same thing as 1,000 metres. And I know that there are 100 centimetres in 1 metre. So 1,000 metres is going to be 1,000 lots of 100 centimetres. So this scale, so I shouldn't really have dot equal signs in it, they're a ratio, aren't they? So 1 centimetre goes with, well, let's times that by 100. That's adding another 2 zeros, isn't it? So it's 1 and then 1, 2, 3 zeros already had, plus another 2 zeros, centimetres. So what's that? That's 100,000 centimetres, isn't it? So 1 centimetre to 100,000 centimetres is the scale. Question 17. On a map, the distance between two towns is 6 centimetres and the actual distance is 1.2 kilometres. Work out the scale of the map as a ratio in its simplest form. Okay, so 6 centimetres represents 1.2 kilometres. What's that in the same number of units then? If really, when I write this ratio, they need to be in the same units. So 1.2 kilometres, we know that there is 1,000 metres in 1 kilometre. So multiplying that by 1,000 is 1,200 metres. And there are 100 centimetres in a metre. So multiplying that by another 100, I'm going to get 1,200,000 centimetres. So then my ratio is going to be my 6 centimetres to my 1,200,000 centimetres. Now I can cancel that down because 6 and 12 are both in the 6 times table. So let's divide it by 6 and divide this by 6. 6 divided by 6 is just 1, and 1,200,000 divided by 6 is 2,000,000. Okay, so that's 1 to 20,000. 1 to 20,000. Question 10. Here is a scale drawing. I've got a Ferris wheel, which I'm told is 130 meters tall, and then next to it is a very tall building. And we're told that the height of the Ferris wheel has a height of 130. Well, we knew that already. Work out the height of the building. Okay, so basically what we want to do here is see how many Ferris wheels fit into the building. Okay, now the way I'm going to do that is I am going to look on my ruler at what size this 130 is. Now this is a bit of a virtual ruler, not quite the same as yours. I wonder how it would look on a real ruler. Now, according to the mark scheme, if you measured this with a ruler, you should find that it is 2 centimeters tall from there to there, roughly. And then if you measure the very tall building, you should find that from there down to there measures 10 centimeters. Now my ruler, you'll notice, doesn't have any marks on it, so I can't really show you that, but that's what the mark scheme tells me. So you should, if you measure it correctly and your paper's been reproduced properly, have 2 centimeters and 10 centimeters in here. In other words, the building is 5 times taller than the Ferris wheel, isn't it? Because 10 divided by 2, so the scale factor of these two buildings is 10 divided by 2, which is 5. Okay, so the building is 5 times bigger than the Ferris wheel. Now we're told that the Ferris wheel is 130, so then the height of the building is going to be the height of the Ferris wheel, which is 130 meters, times a scale factor of 5. So tapping that into my calculator, I should get 130 times 5, 650 meters tall. Oops. 650 meters. Question 15. Here is a map showing 2 towns P and Q, and 1 centimeter represents 50 kilometers. So work out the actual distance between the towns P and Q. So we need to know the distance between these two. So we're going to need a ruler. Now you'll notice my ruler doesn't have any numbers on it, and actually I don't really want to try and use it to measure this distance because this is on my computer screen and it might not be accurate. But what you want to do on your paper is to carefully measure this distance with a ruler. Okay, now I'm told from the mark scheme that is actually 7 centimeters from there to there. Now, it might be that you're doing this on a practice paper that your school has printed out for you. Now again, sometimes when these papers are reproduced by reprographics departments in school, they get slightly stretched or squished. They're not quite the same size as the original paper. So when you measure this on your ruler, on your practice paper, it might be slightly out. But don't worry, the real paper will be real, and you'll be able to measure that with your ruler as long as you know how to use a ruler. So I've measured that, and anyway, it's 7 centimeters. How am I going to work out the actual distance then? So 1 centimeter is 50 kilometers. So 7 centimeters is going to be 7 times 50 kilometers, isn't it? 7 times 50 is 350 kilometers between those two towns. So work out the actual distance. It's 350 kilometers. Now, town R is 200 kilometers due south of town P. Mark R on the map. So we need to draw a line due south of line P. So we need to draw a line straight down there. I don't think we need to construct it in any way. We just need to try carefully draw in a southerly direction for a distance of 200 kilometers. So 200 kilometers, if I want to work out how far I need to draw, I need to divide that by 50 this time. Don't like to work out the number of centimeters. So how many 50s going to 200? It's 4. So I need to draw my line 4 centimeters down. So you can maybe use... I'm losing my voice here. So you can maybe use this edge down here to help you align your ruler nicely so it's going directly down, and then measure a distance of 4 centimeters directly down from P. I'm just going to have to guess because, like I say, my ruler won't match up with the diagram. So it'll be somewhere like that after you've measured carefully 4 centimeters downwards using your ruler. And then you're going to, don't forget to do this bit here, mark R on the map. So if you don't write R, you may lose a mark. So there we go. So it'd be somewhere down there. Like I say, I didn't do that accurately because my ruler is rubbish. It's got no numbers on it. Question 17. Here is a map of an island with cities A, B, and C. The straight lines represent roads. And we've got a scale on the side. We've got 1 centimeter represents 200 kilometers. A is due west of B. Write down the bearing of A from B. So, A is due west of B. Write down the bearing of A from B. So we're starting from B. If we draw a north line at B, because that's where we're setting off from. So let's just draw a north line on B. So north line is just a line going straight up in the same direction as the other north line I've been given. Then the bearing is always given clockwise from that north line. So if I want to walk from B to A, I'm going to be heading in this direction. Okay, which is 3/4 of a turn, isn't it? So 3/4 of 360 or 90, 90, 90. It's going to be 270 degrees. So the bearing of A from B is 270 degrees. Just take careful of this language of from, just to make sure you know where your starting point is and the direction you're going. Okay, what does B say? B says, Umar drives from A to B on the route shown. Kaz drives from B to C on the route shown. Use the map to work out how much further Umar drives than Kaz. Umar drives from A to B on the route. Kaz drives from B to C on the route. So Umar is going from A to B. That's Umar. And then Kaz is going from B up to C, then from here along here and then up to here, up to C. So that's Kaz's route. And these two other dimensions are 2.7 centimeters and 2 centimeters, which together 2.7 plus 2 gives you 4.7 centimeters for Kez's journey. Okay, so you got 6.5 centimeters and 4.7 centimeters. Now, don't forget that 1 centimeter represents 200 kilometers. So taking my 6.5 times it by 200, that will tell me how many kilometers that have been traveled. 6.5 times 200 is 1300 kilometers. And then 4.7 times 200, what's that? That is 4.7 times 200, that's 940 kilometers. I've forgotten what the question is now. What did the question say? The question said, use the map to work out how much further Umar drives than Kaz. Well, then that is going to be a subtraction, isn't it? I'm going to then subtract Umar's journey, which is 1300, subtract Kaz's journey, which was, what was it again? 940. So 1300 subtract 940. 1300 subtract 940. So they did an extra 360 kilometers then. 360. Here is a map of France, and we can see we've got several cities marked on the map, and we've got a scale down here. says 1 centimeters represents 80 kilometers. Okay, what's the question ask? Over the page. What is the 3-figure bearing of Lyon from Bordeaux? The 3-figure bearing of Lyon from Bordeaux. So we're going to start in Bordeaux and we want to go to Lyon. Okay? Right, so you'll notice at the top here we've got a direction line for north, and 3-figure bearings are always measured clockwise from north. So let's just get my ruler out. So straight up in the direction of that north line, look, that's north. So if I want to measure a bearing, I should really start by putting a north line on the point where I want to measure my bearing from. So I want to go directly north from Bordeaux. So drawing an up arrow from there. Okay, so that's my north line. And from Bordeaux, I want to go in this direction, don't I? Oop. Now, so using a protractor, what you want to do is you want to measure that angle in there. Okay? Can't really show a protractor so well in this particular application. But if you plonk your protractor on and measure it, you should find that you get an angle of 84 degrees in there. 84 degrees. And then, so to write that down as a bearing, 84 degrees has only got 2 digits. Okay, we haven't got 84. We've got 85 or 95 or 175 or 05. Okay, so I think that perhaps I was just a little bit out of my measurement. I'm going to say it's that one there, 085. It says work out the actual straight line distance from Paris to Marseille. Work out the actual straight line distance from Paris to Marseille. So Paris is up there in the north, look, and Marseille is down in the south. So let's join them up with a straight line. Now with your ruler, you're just then going to measure that carefully then. Count the number of centimeters is between Paris and Marseille. Now again, because I'm using an emulated ruler here, I'm not going to be able to accurately measure it to show you, but if I did get a ruler out, I think it is around about 8.2 centimeters. Now if you're working from a practice paper from your school because they printed it out for you, sometimes these things don't get reproduced correctly at the right size, so you might find that yours is slightly bigger or slightly smaller. Don't worry too much about that. It's just one of those things that happens when schools give their students practice papers. What you just need to make sure you do is you take whatever measurement you've got there and you multiply it by the length to get the you multiply it by the scale factor in order to get the correct distance. So the scale factor is 1 centimeter represents 80 kilometers, and I've got 8.2 centimeters. Each one of those centimeters is 80 kilometers. I'm going to have to multiply these two things together. Okay, so again, using Napier's Bones grid, I'll do my 8.2 times 80. 8 8s are 64, 2 8s are 16, 8 zeros, well, 0 and 0. What's that then? Adding up along the diagonals, that's 0, 6, 5, 6. So reading around my answer, around the edge here, I've got the digit 6560. Now remember I had one number behind the decimal point there, so I'm also going to have one down here that's behind the decimal point. So my answer is 656.0 or 656. kilometers. So what is the actual distance? It's 656 kilometers. Again, if you're working on a reproduced practice paper that's been photocopied by your school, it might be that it got stretched or squished a little bit. So your answer might be smaller or bigger than that. Don't worry about too much. As long as you multiplied it correctly by 80, I'm sure you've got the answer. Right, question 16. We've got 3 people, Ali, Bayo and Carly, which handily have the initials A, B and C, start walking from point P at the same time. They all walk at 4 miles per hour. Ali walks on a bearing of 0.75. Bayo walks on a bearing of 165. And Carly walks on a bearing of 230. Now you remember that bearings are always given clockwise from north. So that bearing of 0.75 means that they are walking from a 75-degree angle from the north line. Okay, so looking on our diagram here, I know that that angle between the N line and A has got to be 75 degrees. Now, the angle between A and B, well, we know that B is on a bearing of 165, but we've already got this angle of 75 taken out of it. So 165 less 75 would give me 90. So that angle there is a 90-degree angle. And then I've got this angle here. We know C is on a bearing of 230, but I've already got my 75 and my 90 angle taken out of that. So if I want to work out that one there, it's going to be 230 subtract 75 and 90. So 75 and 90 together is 165. Take that away from 230, leaves me with 65. So that angle there is 65 degrees. Okay. Now you can see they don't look like that, but this is not drawn accurately. So how long does it take Ali to walk 1 mile? Oh, it's got nothing to do with the bearings, is it? Right, how long does it take Ali to walk 1 mile? Well, she's walking at 4 miles per hour. So if she can walk 4 miles in 1 hour, then to walk 1 mile, it's going to be a quarter of that, isn't it? 0.25 hours. So what's that in minutes? What's a quarter of an hour in minutes? It's 15 minutes. Okay. Bayo says, after 1 hour, Ali and Carly have walked 4 miles each. 4 miles and 4 miles equals 8 miles, so they are 8 miles apart. Is she correct? Well, clearly she is not correct, because they would be 4 miles apart if they were, 8 miles apart if they were walking in totally opposite directions. So if we had P here and we had A going off in this direction 4 miles and C going off in this direction for 4 miles, then clearly they would be 4 miles apart, but they're not. Actually, what happens is something more like this. So then the distance between them is going to be less than the 2 4s added together. So the reason for that is they are not walking in opposite directions. And C says, who is closer to Bayo after 1 hour? Ali or Carly? Okay, so who is closer to this guy after 1 hour? Is it A or C? Now, okay, I was beginning to think whether or not we'd wasted our time working out those angles earlier, but now I see that we haven't. Because this angle here, this 65-degree angle, is smaller than this 90-degree angle, it means then the distance between here and here must be less than the distance from here to here. So I would say that C and B are going to be closest together because this angle between them is smaller. Okay, so that's what I'm going to write down as my response. So who is closer to Bayo after 1 hour? It is Carly. And why is it? The angle between B and C is 65 degrees, and between B and A it is 90 degrees, and so BC is shorter than AB. Katie is facing north. She does a 3/4 turn anti-clockwise. She then turns 135 degrees clockwise. What direction is she now facing? Okay, well, now remember you're going to have a clock in the exam room, aren't you? So you can have a look at which way round the hands are going if you can't remember. But anti-clockwise is that way round, and clockwise is the way the clock hands are going, that way round. So if we are turning 3/4 turn anti-clockwise from north, we're going to end up doing a 3/4 turn around to this direction, aren't we? If she then does 135 degrees clockwise turn, we're going back the other way, aren't we? The way we just came. Now 90 degrees is a right angle and 180 degrees is a straight line. So 135 degrees is somewhere in between. It's going to be about like that, isn't it? That's 135 degrees. What direction is she now facing? Well, the angle between there and there is 90. So if I add on the 135, 90 plus 135 gives me an answer of 225. So she's on a bearing of 225 degrees. Question 8. Here is a map of a town, and you can see on the diagram here we've got various things marked on it. We've also been given up here a scale. 1 centimeter represents 200 meters, so we can work out how far things are from each other. And we've also been given a direction up here, so this way is north. Okay, so I'm sure that's going to come in useful for the question. What is the question? Which place is exactly northwest of the station? Circle your answer. Okay, so compass points. They've given us north there. You should know that opposite north is south, and then you've got west and east like that. And then between north and east you have northeast. Between south and east you have southeast. Between south and west you've got southwest. And between north and west we've got northwest. So we want to know what's northwest of the station. So northwest is in that direction, isn't it? So if we start at the station and we go northwest, let's just get my ruler out to demonstrate that. So northwest is that direction, isn't it? So starting at the station and going northwest, you can see that the line goes straight to the library. So the answer is the library. Okay, so let's ring that one. Next it says, circle the 3-figure bearing of the monument from the park. Okay, so 3-figure bearings are the angle measured clockwise from north. North is considered to be 0, 0, 0, and then if you measure around to the direction you want to go in, then you can find your bearing. So the 3-figure bearing of the monument from the park. So going to the monument from the park, well, you can see you're going directly to the monument from the park is going directly downwards, isn't it? So let's just mark that on. It's going that direction. Okay, so we said this way is north, so I'm going an angle of 180 degrees around from the north line. So that is going to have a bearing of 180. That one. Any more? Yes. 8C says, what is the distance in meters from the cinema to the station? So cinema to station. Again, I'm just going to join those up with a ruler so I can see them. Now this is a bit of a slant line. So we could measure it, I suppose, because we've got the scale in centimeters. So we can measure it with the ruler and then and multiply it by the number of centimeters by 200 meters, and we'll find the distance. Now my ruler here is a kind of electronic one. It's not going to calibrate nicely with that page, but if you've got a proper ruler on a proper exam paper, you can just measure it to the nearest millimeter. And having done that properly, I made it 5.8 centimeters when I measured it on the real paper with a real ruler. So if it's 5.8 centimeters and I know that 1 centimeter represents 200 meters, if I times 200 by 5.8, I should get the distance. So 200 times 5.8, what's that equal to? Let's reach for the calculator. 200 times 5.8, that gives me 1,160. 1,160 meters, so that's my answer. There's probably a little bit of leeway either side. Probably you're allowed anything from about 1120 up to 1200, I'd imagine, but I made it 5.8, which is 1160. Finally, 8D says, why might the shortest walking distance from the cinema to the station be greater than your answer to part C? Okay, so why might the shortest walking distance from the cinema to the station be greater than your answer? Well, if you come back to the diagram here, you can see that this path is direct, and there might be things in the way. This monument there might be a fence around this monument that you have to then go around. So the actual walking distance might be longer than the direct route because there might not be a path all the way through. So I'm going to write something like that down. So why might the shortest walking distance be greater than your answer? There may be obstacles in the direct path so pedestrians would need to walk around these. Something like that. So there may be obstacles in the direct path, so pedestrians would need to walk around these. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.